In a setup with a main breaker box and a main lug load center, even when they are immediately adjacent, it is treated as a subpanel configuration. This means that the neutral and ground buses must be kept separate in the load center. Here's how to properly connect the grounds and neutrals. For grounding, firstly, run a separate ground wire from the main breaker box grounding bus to the ground bus of the load center. This wire provides a dedicated path for fault currents. Secondly, connect all equipment grounding conductors, or EGs, in the load center to the ground bus. These conductors are the ground wires that run with the branch circuits to provide a low impedance path for fault currents back to the source. Thirdly, install a grounding electrode conductor, or GEC, from the main breaker box grounding bus to the grounding electrode system, such as a ground rod or a water pipe. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage to earth during normal operation and provides a path for fault currents in the event of a ground fault. For neutrals, do not connect the neutral bus of the load center to the grounding bus. This is a critical point in a subpanel configuration. Secondly, run a neutral wire from the neutral bus of the main breaker box to the neutral bus of the load center. This wire carries the unbalanced current from the branch circuits back to the source. Thirdly, connect all ungrounded, or hot, conductors to the appropriate breakers in the load center. These are the wires that supply power to the various circuits in the building. Fourthly, connect all neutral conductors to the neutral bus. These are the return wires for the branch circuits that carry the unbalanced current back to the source. It is important to emphasize that in a subpanel configuration, the neutral and ground buses must be separated. This means that one should not install one service ground and connect both the neutral and ground wires to it. This separation is essential for safety and to prevent neutral currents from flowing through the grounding system. This can cause nuisance tripping of ground fault circuit interrupters, or GFCIs, and can also create a shock hazard. Some additional notes to keep in mind: firstly, the size of the ground wire and the GC must be based on the size of the main service entrance conductors. Consult the National Electrical Code, or NEC, Table 250.122 for the proper sizing of equipment grounding conductors, and Table 250.66 for the proper sizing of grounding electrode conductors. Secondly, the neutral and ground wires should be kept separate throughout the entire system. This means that they should not be bundled together or run in the same conduit unless specifically permitted by the NEC. Thirdly, it is not recommended to share neutrals between the main breaker box and the load center. Each panel should have its own dedicated neutral conductor. It is always best to consult with a qualified electrician, especially if there are any doubts or uncertainties about the proper wiring method. Electrical work can be dangerous, and it is important to ensure that all work is performed in accordance with the NEC and local codes. Grounding and bonding are critical aspects of electrical safety. The purpose of grounding is to provide a low impedance path for fault currents to return to the source, which helps to trip the overcurrent protective device, such as a circuit breaker or fuse, and to energize the circuit. Bonding is the process of connecting all metal parts of the electrical system together to create a common ground potential. This helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC provides detailed requirements for grounding and bonding in Article 250. It is important to understand these requirements and to follow them carefully to ensure a safe and reliable electrical system. In summary, when connecting grounds and neutrals in a subpanel configuration, it is essential to keep the neutral and ground buses separate. This means running a separate ground wire from the main breaker box grounding bus to the ground bus of the load center, connecting all equipment grounding conductors to the ground bus, and installing a grounding electrode conductor from the main breaker box grounding bus to the grounding electrode system. The neutral bus of the load center should not be connected to the grounding bus, and a separate neutral wire should be run from the neutral bus of the main breaker box to the neutral bus of the load center. All ungrounded, hot conductors should be connected to the appropriate breakers in the load center, and all neutral conductors should be connected to the neutral bus. By following these guidelines, one can ensure a safe and compliant electrical installation. Remember to always consult with a qualified electrician if there are any doubts or uncertainties. Understanding the correct way to connect grounds and neutrals is crucial for ensuring electrical safety in any subpanel setup. The separation of neutral and ground buses is a fundamental principle that prevents unwanted current flow and minimizes the risk of electrical shock. The ground wire provides a dedicated path for fault currents, while the neutral wire carries the unbalanced current from branch circuits. By maintaining this separation, the grounding system can effectively protect against electrical hazards. It's important to note that the size of the ground wire and the grounding electrode conductor must be appropriate for the size of the main service entrance conductors. The NEC provides specific tables for determining the correct wire sizes based on the amperage rating of the service. Also, it is generally not recommended to share neutrals between the main breaker box and the load center. Each panel should have its own dedicated neutral conductor to avoid overloading the neutral and creating potential safety issues. When working with electrical systems, it's always best to err on the side of caution. If there are any doubts or uncertainties, consult with a qualified electrician who can provide expert guidance and ensure that the installation meets all applicable codes and standards. The NEC is the primary resource for electrical safety requirements in the United States. It is updated every 3 years, and it contains detailed information on grounding, bonding, wiring methods, and other aspects of electrical installations. It is essential for electricians and other electrical professionals to stay up to date on the latest NEC requirements to ensure that their work is safe and compliant. Electrical safety is a critical concern for everyone, and understanding the basics of grounding and neutral connections is an important step in preventing electrical hazards. By following the guidelines outlined in this discussion and consulting with qualified professionals when needed, one can help ensure a safe and reliable electrical system. Furthermore, consider the practical implications of these connections in different scenarios. For instance, in a residential setting, a subpanel might be used to supply power to a detached garage or a workshop. In this case, it is crucial to follow the subpanel wiring guidelines to ensure that the neutral and ground are properly separated. In a commercial setting, subpanels may be used to distribute power to different areas of a building or to specific equipment. Again, the same principles apply. The neutral and ground must be kept separate, and all connections must be made in accordance with the NEC. In addition to the specific wiring requirements, it's also important to consider the overall design of the electrical system. This includes things like load calculations, circuit breaker sizing, and wire selection. A well-designed electrical system will be safe, reliable, and efficient. It's also important to regularly inspect and maintain the electrical system to identify and address any potential problems before they become serious. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. By taking these steps, one can help ensure the long-term safety and reliability of the electrical system. Also, it is imperative to remember the importance of using the right tools and equipment when working with electricity. This includes insulated screwdrivers, wire strippers, and voltage testers. Always to energize the circuit before working on it, and use a voltage tester to confirm that the circuit is dead. Never work on live electrical equipment unless absolutely necessary, and always follow proper safety procedures. Remember the importance of personal protective equipment, or PPE, when working with electricity. This includes safety glasses, gloves, and appropriate clothing. PPE can help protect against electrical shock, burns, and other injuries. It is better to be safe than sorry when it comes to electricity. If one is not comfortable working with electricity, it is best to call a qualified electrician. Electricity can be dangerous, and it is important to know one's limits. Remember that electrical codes and regulations vary from place to place. It is important to check with the local authorities to ensure that the work is in compliance with all applicable codes. The NEC is a national standard, but local codes may have additional requirements. Following these guidelines will help one to ensure the safety of the building. A properly installed and maintained electrical system is essential for the safety and well-being of everyone who uses the building. By taking the time to learn about electrical safety and to follow proper procedures, one can help prevent electrical accidents and injuries. And remember, when in doubt, consult with a qualified electrician. Their expertise can help one to ensure that the work is done safely and correctly. The importance of regular electrical inspections should also be remembered. Inspections can identify potential problems before they lead to major issues or hazards. These inspections should be performed by qualified professionals who can assess the condition of the wiring, connections, and other electrical components. During an inspection, the electrician will look for things like loose connections, damaged wiring, overloaded circuits, and other potential problems. They will also check to make sure that the grounding and bonding systems are properly installed and functioning correctly. If any problems are found, the electrician will recommend repairs or upgrades to address the issues. Regular electrical inspections are particularly important in older buildings where the wiring may be outdated or damaged. They are also important in buildings that have undergone renovations or additions, as these changes may have affected the electrical system. In addition to regular inspections, it is also important to be aware of the signs of potential electrical problems. These can include things like flickering lights, tripped circuit breakers, and warm or discolored outlets. If one notices any of these signs, it is important to investigate the issue and to call an electrician if necessary. Ignoring electrical problems can lead to serious consequences, including electrical fires and shocks. So be vigilant and take action if anything seems amiss. Also consider the environmental factors that can affect the electrical system. Moisture, temperature, and corrosion can all damage electrical components and lead to problems. It is important to protect the electrical system from these elements as much as possible. This can include things like using weatherproof enclosures for outdoor electrical equipment, sealing penetrations in walls and floors to prevent moisture intrusion, and using corrosion-resistant materials in areas where corrosion is a concern. Remember that electrical safety is an ongoing process, not a one-time event. By staying informed, being vigilant, and taking action when necessary, one can help ensure the safety of the building and its occupants. So prioritize electrical safety and make it a part of the routine. Always consult with qualified professionals when needed, and never hesitate to ask questions. The more one knows about electrical safety, the better prepared one will be to prevent electrical accidents and injuries. Lastly, it is crucial to document all electrical work that is performed. This includes keeping records of inspections, repairs, and upgrades. Documentation can be helpful for future maintenance and troubleshooting, and it can also be required by local codes. When documenting electrical work, be sure to include details such as the date of the work, the name of the electrician who performed the work, and a description of the work that was done. It is also a good idea to take photos or videos of the work, especially before and after any repairs or upgrades. Documentation can be stored in a physical file or electronically. Just make sure that it is easily accessible when needed. Also remember to keep track of any permits that are obtained for electrical work. Permits are often required for major electrical projects, and they help to ensure that the work is done in accordance with local codes. By following these guidelines, one can help to maintain a safe and compliant electrical system and protect the building and its occupants from electrical hazards.